Hi, good evening, everybody. Hope I'm audible. Yeah.
ಸಾಯಿಂಗೆ ಮಾಡ್ತಾರೆ
Madam, can you please give the host access again?
తాగి తాగిన పిల్లలు
కదా మనం చేయకూడదు ఇస్లో ముదిరిపోయింది కదా.
Okay. So in our last class, we have started IS 104. So I'll just take a quick overview. Once you're able to see my screen, say yes. It is still loading. Yeah. You could able to see my screen now. Okay. So we have started with IS 104, which is a quality control in occupational health and safety and environment. So the topic is hazard identification and techniques. We have seen what is mean by hazard. Then we have seen hazard detection techniques. Then we have seen risk analysis, risk assessment, risk management. Okay. Then we have discussed about other methods as well. Even we have seen risk control measures also. Then we also discussed the risk manager duties. Then we have covered a preliminary hazard analysis. Then we have covered a failure mode effect analysis. I think we are about to complete this. So as I mentioned, the failure mode effect analysis, it is completely the focuses on the performance of the equipments. As you see in the last paragraph, this knowledge can be used to improve the life and quality of the product. And this is thus it is primarily more useful to the manufacturer than it is user. So based on this, they do testing of all the equipments. Basically, mostly they do automobiles and other engines, motors, etc. Accordingly, they will suggest the service conditions, even replacements, etc. As I taken an example of last time, automobiles, they used to give an offer for up to 1 lakh kilometers or some service or free, etc., etc. They will give. ఇది ఎక్కడ యూజ్ చేస్తారంటే ఎక్విప్మెంట్స్ ని టెస్ట్ చేయడానికి. ఇక్కడ ఏంటంటే దే విల్ నాట్ సీ ద మాల్ ఫంక్షన్, విచ్ మీన్స్ ద ఆపరేటర్ ఇఫ్ డజన్ మిస్టేక్, they won't count here. So here they purely test the equipment or the motor or engine, how it is performing. ఏంటంటే ఇక్కడ మనుషులు చేసే తప్పిదాలని వీళ్ళు కన్సిడర్ చేయరు. ఇది ఎందుకు అంటే టు సీ the reliability of the equipment. In this page, I mean, it will give you a better understanding what exactly this FMEA works for. So here, the failures. So the probability of occurrence can be experienced in terms of an average time between failures. So probable one failure before 1,000 hours of operation. Reasonably possible one failure during 10,000 to 1 lakh hours of operation. A remote one failure from 1 lakh to 10 million, and extremely remote one failure for 10 millions of operation. So the failure frequency data is difficulty to obtain. It is obtained from two types of testing of the components, that is performance test or reliability test. So this is how they test. For example, ఒక్కసారి ప్రాబబుల్ అంటే ఓకే, ఒక 10,000 అవర్స్ నేను కనుక నా మెషిన్ రన్ చేస్తే ఒకసారి ఫెయిల్ అయ్యే ఛాన్స్ ఉంది. సో రీజనబుల్లీ పాసిబుల్ అంటే మేబీ 10,000 to 1 lakh, కొంచెం దగ్గరగా. రిమోట్లీ అంటే ఎప్పుడో, సో 1 lakh నుంచి ఒక 10 లక్షల వరకు. ఎప్పుడో రేర్గా అవుతుందంటే ఎక్స్ట్రీమ్లీ రేర్. ఎక్స్ట్రీమ్లీ రిమోట్ మీన్స్ ఎక్స్ట్రీమ్లీ రేర్, అయ్యే ఛాన్స్ లేదు టిల్ 10 million hours of failure, which means అప్ టు 10 లక్షల గంటలు రన్ చేస్తే నాకు ఒక్కసారి నా ఎక్విప్మెంట్ అనేది ఫెయిల్ అవుతుంది. సో ఇఫ్ యు సీ అన్ ఆటోమొబైల్, we used to do the bore. I don't know exactly what they do. We used to, in our nomenclature, bore చేపిస్తున్నాం అంటారు. So it means that is an ultimate failure. Even though you do service, even though you do a number of oil changes, the bore will be okay, ek baar to pura mar gaya, abhi shuru hai, I mean second life. So that is the kind of this thing. So the failure classification distinguishes between possible effects of assumed failure, and a 4-part classification is safe, marginal, critical, or catastrophic, indicating increasing the severity. So based on this testing, they will classify, okay, it is safe or marginal, critical, or catastrophic in case of any damage happens. Okay, that is about FME. So basically in exam, they will not ask you for these numbers and all. They will ask you to explain FMEA, failure mode effective analysis technique. So this slide will be more than sufficient. The slide number 18. Now we'll see hazard operability study. It is widely accepted and used and using technique. So ఇంతకుముందు use చేశారు, but still it is using as well, especially in the I can say chemical, petrochemical, pharmaceutical industries. So if you see in a hazard, it is in a multidisciplinary team, such as deviations from a design intent through a fixed set of guide words or checklist or knowledge. So basically, who does this? A multidisciplinary team. So basically, ఈ hazard study అనేది different departments people together they do. So when you say, it talks about search, what they are searching for, deviations from a design intent. అంటే ఏంటి, నా ఇంటెన్షన్ తోటి నేను ఒక డిజైన్ ని క్రియేట్ చేశాను. సో ఫర్ ఎగ్జాంపుల్, వాట్ ఎగ్జాంపుల్ విల్ టేక్, Okay. So I take an electric circuit as an example. So I have done my housing wiring. I have a central control system in my living area. So if I press a switch called a switch A in my first bedroom, it has to glow the light. When I click on second switch, it has to activate the fan. When I click the third switch, it has to activate bulb in my washroom. So that is my intended design. That అది నా రిక్వైర్మెంట్. నేను దాని ప్రకారంగా నేను నా వైరింగ్ అనేది చేసుకున్నాను. So we know the first switch is for to glow the lights in the bedroom, and second switch is to activate my fan, and third switch is to activate my light in a washroom. So this is my design intent. Now what they do, they'll search for the deviations. So they have done the design. Now they are testing it. Okay, when I click on first switch, when I operate on first switch, my design intent is it has to glow light in the bedroom, but it is activating the fan. So that is the deviation. I'm taking the simple example. So that is the design or deviations from the design intent. Intent means that is intention or your requirement. Okay. ఇదేంటంటే మనము ఎలా కావాలనుకుంటున్నామో అలా మన సిస్టమ్ అనేది పని చేస్తుందా లేదా అన్న దాని గురించి ఈ హజాబ్ అనేది చెప్తుంటుంది. అందులో డీవియేషన్స్ ని ఐడెంటిఫై చేస్తారు. ఎవరెవరు చేస్తారు? అందరూ కలిసి. మల్టీ డిసిప్లినరీ అంటే సో ప్రాసెస్ సేఫ్టీ దగ్గర నుంచి మెయింటెనెన్స్, ఇన్స్ట్రుమెంటేషన్, ఎలక్ట్రికల్, ఇన్ ద మెయింటెనెన్స్ అగైన్ ఎలక్ట్రికల్, మెకానికల్, ప్రొడక్షన్, క్వాలిటీ, R&D, safety, process safety. Everybody is involved in this. Okay, HACCP can be conducted to check the designs or operating procedures for a new project or an existing one. So దీని ఏం చేయొచ్చు? సో కొత్త ప్రాజెక్ట్ కైనా చేయొచ్చు, సో ఎగ్జిస్టింగ్ అంటే పాత ప్రాజెక్ట్ కైనా చేయొచ్చు. It can also be conducted to improve safety of existing facilities. It is also useful before implementing significant modifications or for other operational or legal reasons. So ఎప్పుడు చేయొచ్చు? It is useful before implementing any significant modifications. For example, already my existing housing wiring is there. So previously I didn't have any central control system. So nowadays everybody is going for AI technology or with Alexa control. So they are, I can say, digitalizing, not getting the exact word. Automation. So when I say that is a significant modification in my basic wiring system, house wiring system. So when we do this significant modifications in your process, then it can be useful, or other operational or legal reasons. In case of your product is being banned or you're going for a new project or new process, also can be done. ఎప్పుడు చేయొచ్చు? మీ ప్రాసెస్ లో ఎప్పుడైనా పెద్ద మార్పులు చేసినప్పుడు మనం ఈ హజాబ్ ని యూజ్ చేసుకోవచ్చు. So after carrying out the preliminary hazard analysis, PHA, or explained, I mean, as we seen earlier, the plant component, system, or a machine equipment part which can be cause a major hazard become known to us. Now to find out the deviations or malfunctions leading to such event and it made of operation, HACCP helps us, and HACCP is a complementary to PHA. So basically ఏంటంటే in case after carrying out the preliminary hazard analysis, a plant or system, machine or equipment part which can cause a major hazard becomes known to us. అంటే PHA చేసిన తర్వాత ఏదైనా మేజర్ హజార్డ్ ని మీరేమన్నా కనుగొనగలిగితే, దట్ ఈస్ ప్రిలిమినరీ హజార్డ్ అనాలిసిస్. దాంట్లో ఏంటి, మనం ఏం చేస్తాము? హజార్డ్ ని రిస్క్ ని ఐడెంటిఫై చేస్తాము. అక్కడ ఏదన్నా మేజర్ హజార్డ్ని ఐడెంటిఫై చేస్తే అగైన్ హజాబ్ ఈస్ గోయింగ్ టు హెల్ప్ అస్. అంటే హజాబ్ స్టడీ అనేది, హజార్డ్ ఆపరబిలిటీ స్టడీ అనేది ఈ మేజర్ హజార్డ్ ఉండడానికి గల కారణాలని కనిపెడుతుంది. సో వీ కెన్ ఏబుల్ టు ఐడెంటిఫై the possible deviations for this malfunctioning. So HAZARD is a complementary to PHA. It is going to be an advanced version, we can say, for PHA. So HAZARD study is carried out to determine the deviations from normal operations and operational malfunctions which can lead to a uncontrolled events. So ఎందుకు చేస్తాము? నార్మల్ ఫంక్షన్స్ అంటే ఏంటి? ఒక మిషన్ ఎలా పనిచేయాలో అలాగే పనిచేయాలి. నేను ఫస్ట్ స్విచ్ చేసినప్పుడు లైట్లే వెలగాలి, ఫ్యాన్ తిరగకూడదు. రెండో స్విచ్ చేసినప్పుడు ఫ్యానే తిరగాలి, లైట్లు వెలగకూడదు. సో అది మన నార్మల్ ఆపరేషన్. అట్లా కాకుండా నేను ఫస్ట్ స్విచ్ చేసినప్పుడు ఫ్యాన్ తిరిగి సెకండ్ స్విచ్ చేసినప్పుడు లైట్లు వెలుగుతున్నాయి అంటే ఇట్ ఈస్ ఎ మాల్ ఫంక్షన్. సో ఇట్ ఈస్ నాట్ సపోజ్ టు బి హ్యాపెండ్. సో ఏమవుతుంది? ఇన్ అవర్ కేస్ వీ హ్యావ్ టేకెన్ సింపుల్ ఎగ్జాంపుల్. ఇఫ్ యూ టేకెన్ కెమికల్ ఎగ్జాంపుల్, దెర్ ఆర్ 3 chemicals ABC. So I have done a programming, digital programming as in a DCS control. Initially, the chemical A has to come into the reactor. After 10 minutes of agitation, chemical B has to come. Then after 1 hour of agitation of these 2 chemicals, A and B, the C has to come in. But initially the A came in. Then on the second, the C chemical came into my reactor. That is a deviation. It is not supposed to be. If I mix A and C in the initial stage of the reaction, it can lead to exothermic, or there is a high chance of the failure of the product as well. That is the uncontrolled events. So either maybe an accident or explosion, etc., etc. So although the HAZARD study was developed to supplement experience-based practices, when a new design or technology is involved, its use has expanded to almost all the phases of the plant's life. It is based on the principle that several experts with different backgrounds can interact and also identify more problems when working together than the working separately and combining their results. Okay. The HAZARD studies are developed to supplement experience-based practices when a new design or technology involved, and also it used in expanded to almost all the phases of the plant life. So every phase, maybe in the initial design phase or installation phase or running phase, or again after a long-term shutdown, again we are restarting the plant. In that time also we can use this. It is based on the principles and experts. So we use different or multiple experts to give their suggestions, and also they can find the more problems and they can give better solutions instead of doing alone. So everybody have their own perspective, or if 10 people are sitting together and if they're analyzing the situation or doing the investigation, in such a case the outputs are different. అంటే ఏంటంటే ప్రతి ఒక్కళ్ళు ఇండివిజువల్ గా కూడా అసెస్ చేయొచ్చు ప్రాసెస్ ని. సో అలా కాకుండా ఏంటంటే, సో అందరూ కలిసి if they assess together, so the results will be more productive. Therefore, as a study is performed by multidisciplinary experts group, always including workers familiar with the installation. So here, who familiar with the installation? It means the process, how the process is going, how the lines are done. All this should be known. Then only the study will be easy. The examination procedure takes a full description of the process, systematically questions every part of it to discover how deviations from intention of design can occur, and also decides whether these deviations can gives rise to a hazard. So basically, here it talks about the description of process. So we'll understand the complete process and systematically questions every part. So here we'll question the each part of the process. When I say a single line diagram or process flow diagram, so basically how it works. So the process flow diagram starts from the chemical which will comes from the storage, then it will pump it to the intermediate storage. From there, it will come to the process reactor. Once it is done, it will go for the finished good storage. From there, it will go for a packing or a distribution. This is how systematically we'll ask. Okay. Then here we'll identify the deviations from the design and decides whether these deviations can leads to any accidents or leads to any hazards. అంటే ఈ యొక్క ఒక్కొక్క phase లో అంటే ఒక్కొక్క I can say the portion of operations or the part of an operations. We'll ask for the questions, the deviations. Then we'll decide whether these changes or these deviations can result in any hazard. Okay. Then each part of the design is analyzed with questions formulated around the number of guide words, which ensure the question passed to test the integrity of the each part of the design, and will explore every conceivable way in which the design could deviate from design intention, and then deviation is considered. So here the main thing is the guide words. So there are 7 guide words. We'll see in the subsequent slide. So by using those 7 guide words, they will analyze each part in the design. So then they will identify in case of any deviations comes up. Okay. The potential hazard are noted for the remedial actions, then trivial or meaningless consequences are dropped out. So in case of any potential deviation happens, we will take the corrective actions. Any, the less required or any minor deviations, they will not be going to consider. Now we'll see the stages in which the hazard can be carried out. What are the various steps or what are the various stages or situations we can కండక్ట్ దిస్ హజార్డ్. అంటే ఎన్ని రకాలుగా కాదు. సో ఎలా చెప్పొచ్చు అంటే ఎటువంటి సిచ్యువేషన్స్ లో మనం ఈ హజార్డ్ ని కండక్ట్ చేయొచ్చు. Number 1, at early stage of the development to decide the site and identify the major hazards. So before developing of your process itself, and as I take a factory as an example, so I'm looking for a factory where I want to set up near any particular place. If I identified a particular place, there we can see for such locations, okay, whether these location is suitable for my kind of operations. Again, at the design freezing stage, so you have decided, okay, your plant premises were finalized. Now you are going to finalize the process design before freezing. Freezing means you are going to say okay to this design. That is when the design is completed and the construction is going to be started. That is your design freezing stage. And at pre-start stage, when the construction is completed and the operation is to be started. So it can be also done అంటే ఒకటి మీ ఎర్లీ స్టేజ్ డెవలప్మెంట్ అప్పుడు చేయొచ్చు. 2, మీ డిజైన్ ని ఫ్రీజ్ చేసేటప్పుడు అంటే డిజైన్ ఫ్రీజ్ అయ్యి కన్స్ట్రక్షన్ కంటే ముందు అంటే స్టార్ట్ అయ్యే ముందు కూడా చేయొచ్చు. నెక్స్ట్ కన్స్ట్రక్షన్ అంతా అయిపోయిన తర్వాత ఆపరేషన్ ని స్టార్ట్ చేసే ముందు కూడాను we can do this hazard study. Then studies on existing plants. So the first 3 are new plants. From the 4, we can do it for existing. Already the plants are in running. Studies prior to the plant modifications. So ఏదైనా plant ని modify చేసే ముందు కూడా చేయొచ్చు. So studies prior to taking a plant out of service, and studies on research facilities. So again, studies prior to taking plant out of service. So shutdown తర్వాత కూడా మనం మళ్ళీ రీస్టార్ట్ చేస్తున్న ప్లాంట్ ని తర్వాత studies on research facilities. Example, R&D centers. Those facilities also we can analyze by using HAZOP. Now we'll see the procedure of the study to follow the sequence, define objective and scope. And second, select the team. First of all, the objective of the study. So why you are doing it and what will be the scope. If you see a scope, so the limitations, your study is going to be limited for, sometimes we do only for ETP operations. Sometimes we do for STP operations. We do only for one particular product, or we may do it for complete all the products, or we may do only for tank farm area, or we can limit it to only the scrubbing facilities or utility, like that. Scope will be a limitation. I mean, to an extent to your doing it. Then prepare for study, carry out the examination, then follow up and record the results. Then we'll prepare a team, then we'll prepare for study, then we'll carry out the examination in the sense analysis and follow up and recommendation. We'll write for the results, which means the examination results. The objective may be one, to check the design, and second, to decide whether and where to build. So as I take an example of before design stage. And third is to decide whether to buy an equipment. And fourth is to obtain a list of questions to put to the supplier. And fifth is to check running instructions, and also sixth is to improve safety of existing facilities. These are the a few examples of what do you call objectives of HAZOP study. Okay. Fine. Then the team may be composed of. So here you will see the multi-disciplinary team example. So how the team is formed? Here it is composed of a mechanical engineer, a chemical engineer, R&D chemist, the production manager, the project manager, instrument and electrical engineer, the civil engineer, etc. The team should not be too large. The team is headed by an experienced specialist from a works management, or by a specially trained consultant. So the team should be as short as possible, but the multidisciplinary departments, all the department people should be there. And you won't stick with these designations. So only production manager should be there, or either the production engineer is not sufficient. It is not about designation. It is about the people who have a complete knowledge on their process. Okay, ఎవరైనా ఉండొచ్చు. సో మేనేజర్ ఉండడం లేదు, ఎవరికైతే ఎక్స్పీరియన్స్ ఉంటుందో వాళ్ళ యొక్క ప్రాసెస్ మీద, యాక్టివిటీస్ మీద we can choose as a team member. సో ఇక్కడ మనకి మెకానికల్ నుంచి ఉన్నారు, కెమికల్ నుంచి ఉన్నారు, R&D నుంచి ఉన్నారు, ప్రొడక్షన్ నుంచి ఉన్నారు. సో ఇన్స్ట్రుమెంట్ పీపుల్ ఆల్సో we have, even civil as well. Okay. So for all these people, we need a leader. Otherwise, what will happen? Somebody is there to control the arguments. Argument in the sense, discussions. A production guy may say that, okay, whatever his idea is correct. Then chemical engineer will say that, no, your idea is not correct. So somebody should be there to control these arguments. We need to have a management personnel or a third party consultant. Okay. After examining one part of the design and record a potential hazards, if any, the study proceeds to examine the next part of the design, and it is repeated until the whole plant has been studied. If you choose to conduct the complete plant, we'll go by part by part. So we'll do for one part, then we'll make our records, then they'll go for next. They'll not directly jump. they will go as per the process flow. Okay. So these are the important guide words. Here also there is a chance of asking a question. List the 7 guide words. Okay. One is no or not, the meaning and the commitments. Let me zoom it a bit. Okay. Yeah. No or not. The complete negation of this intentions, which means it is completely negative. The comment will be no part of the intention is achieved, but nothing else is happening, which means my intention is not happening. So if I take an electric wiring as an example, when I operate my first switch, what is happening? Nothing is happening. The lights are not activated. Then more, the quantitative increase or decrease, which means here we have more and less, the guide word. This refers to the quantities plus the properties such as flow rates and temperatures, as well as activities like heat and reactions will increase. Here quantitative increase or quantitative decrease. ఏం చెప్పొచ్చు, నేను ఒక్క స్విచ్ చేస్తే 2 ఫ్యాన్లు తిరగొచ్చు, లేదంటే బాత్రూంలో అన్ని లైట్లు వెలగొచ్చు, బెడ్రూమ్లో లైట్ వెలగొచ్చు, ఫ్యాను తిరగొచ్చు, లేదు అంటే ఏదైనా 2 కానీ అది ఏది తిరగకపోవచ్చు అనేది నాట్. మోర్ లెస్ ఏంటంటే తక్కువ ఎక్కువ జరగటం. ఫర్ ఎగ్జాంపుల్, let us leave that electricity example, that is not a right example for this more and less. We'll take in chemical as an example. So quantity increase, so it is supposed to become only 10 liters of chemical. There might be a chance either more chemical comes in or sometimes less chemical comes in. What will be the deviations? Apart from this, they may see for heat and other reaction parameters also will be covered. If it is happens more reaction or less reaction, if the temperature is more or temperature is less, like that. And next guide word, as well as a qualitative increase, a part of a qualitative decrease. When we say as well as, all the design and operating intentions are achieved together with some additional activity. So apart from this thing, for example, the chemical A is coming as per my intention 10 liter. Apart from this, other chemical also coming additionally. That is the as well as, a part of only some intentions are achieved, some are not. In the part of, there are in this situation, as per my intention, 3 chemicals has to come together. I mean, same time, from 3 different pipelines, the chemical has to become. Out of 3, only 2 chemicals are coming. 1 chemical is not adding to my reactor. Okay. Then other guide word, reverse. So not అంటే ఏంటంటే నా ఇంటెన్షన్ అనేది ఫుల్ఫిల్ అవ్వలేదు. మోర్ ఆర్ లెస్ అంటే నా ఇంటెన్షన్ కన్నా ఎక్కువ క్వాంటిటీలో ఉన్న మెటీరియల్ కానీ టెంపరేచర్ కానీ రియాక్షన్ కానీ జరుగుతుంది. లెస్ అంటే నేను కావాలనుకున్న దానికంటే కెమికల్ తక్కువ రావడము, టెంపరేచర్ తక్కువ రావడము, రియాక్షన్ కూడా తక్కువ జరుగుతుంది. యాజ్ వెల్ యాజ్ అంటే నాకు కావాల్సింది జరుగుతుంది, దాంతోపాటుగా ఇంకొక ఎక్స్ట్రా కెమికల్ కూడా వస్తుంది. దట్ ఈస్ నాట్ మై ఇంటెన్షన్. నాకు కావాల్సిందే రావాలి, అడిషనల్గా ఏం రావద్దు. పార్ట్ ఆఫ్ అంటే నాకు కావాల్సిన దాంట్లో సంపోషన్ మాత్రమే వస్తుంది. అంటే 3 కెమికల్స్ రావాల్సినవి 2 కెమికల్సే వస్తున్నాయి, ఒక కెమికల్ రావట్లేదు. ఓకే, దట్ ఈస్ యాజ్ ఆఫ్ నౌ. Then reverse, the logical opposite of the intention. This is mostly applicable to the activities, for example, reverse flow or chemical reaction. It can also be applied to substances, example, poison instead of antidote, or D instead of L, optical isomers. Okay, it is in a reverse. So instead of a B is coming. Instead of B, a C is coming. Okay, it is in a reverse kind of operation. Then other than complete substitution, no part of original intention is achieved, something quite different is happening. So my intention is I need chemical X has to come in. But here the chemical is not coming, the water is coming to my reactor. My intention is chemical X. But water is coming to my reactor. Not a part of original intent. Something else is happening. Maybe here the temperature has to rise. But here the cooling is happening. It is completely different. These are the 7 guide words. They will apply in the each part of the design. Then they come up with the deviations. Okay. So here we have less than a minute. I'm stopping here. So in the second session, we will complete. Meanwhile, if you have any questions, please note it down. We can discuss after the break. Because these guide words are very important. Even in the practically, if you are becoming a part of HAZOP team, you should know all these basics. Because here our syllabus is limited to the basics. We are not doing any assessment, but you should know the basics. Any questions at this moment?
Sir, during this entire process, are we